All right, well, we've talked about nucleophilic addition and also nucleophilic elimination. Well, there's electrophilic addition and electrophilic elimination. So we're going to talk about electrophilic addition in this video. So let's look at an example of that mechanism in action. So in this case, we're going to start off with something that has a lot of electrons available to it, and that is going to attack something that would like electrons. So here's our electrophile. This is something that would like electrons. Remember, electrophiles, Lewis acids. So, yeah, it's appropriate. We have an acid here. Now, I know it's tempting to say, oh, let me draw the arrow going this way. No, that's not the right way. That's what we do with nucleophiles. It has to come from the area of electron density and go towards the area that needs electrons. So we're going to come from this pi bond and go over to that hydrogen, and then again we'll move the electrons over there. So we have the electrons from the pi bond here, which are then going to move over to this electrophile. And this will end up making this. Let's see here, H3C, C. And then we'll have a positive charge left on this carbon here. And it really wouldn't matter which carbon I draw this on. It's a symmetrical molecule, so not important there. Plus our leaving group that left. So we have the electrons from this bond attacking this proton, makes this new bond between the carbon and the hydrogen right there, the proton, and the positive charge ends up over here. Now, this would not be the end of the reaction. We would instead have a coordination step that would follow, and we could have a coordination step that would attach this chloride to that positive charge. But we've already talked about coordination. This is going to focus exclusively on electrophilic addition. But that's what we would expect to have happen. Here, I'll just try here. We would end up with something like this. Now, we could have a mixture of cis and trans isomers, but anyway, have something like that. Let's also look at cyclic or a benzene ring aromatic structure. We have a positive charge on this NO2. Now again, we'll have our double bond attacking the positive charge, and kind of used up my space, so I'll just draw it down here. So let's see here. Drew it from that bond, so we'll just put it on somewhere here. We'll have a positive charge sitting down here, say. Drew this circle kind of small, but there's a positive charge there, and we've done electrophilic addition. Now, again, this wouldn't be the end of the reaction. We would have something else come in and attack that positive charge, but this is the electrophilic addition step. So, comes from our pi electrons and attacks an electrophile. And then we get a new bond that's formed. That's the addition part.